Good morning, sir. I am Ayush Upadhyay and I am going to explain the topic of structural presentation and acyclic or open chain compound. In slide 1, we will see the structural representation of organic compounds. Like we will take an example of ethane C2H6. In this, CH3 is connected with CH3. A compound makes a bond with 3 hydrogen and 1 carbon. Let us take a second example of ethane C2H4. Is double bond between carbon and two hydrogen is connected with each other. In this slide, I will explain a cyclic or open chain compound. A cyclic compound are those compounds in which carbon atoms are linked to each other in linear or branched fashion. These compounds are also called aliphatic compounds. Here are some examples of a cyclic chain compound. Example: acetic acid butane isobutane. Acetic acid CH3COOH butane C4H10 isobutane C4H10.
Good morning, sir. I am Sound Solanki and I am going to explain the topic acyclic or closed chain or ring compounds. Acyclic compounds are those organic compounds with closed chain of atoms and are called closed chain compounds or ring compounds. These compounds are classified into two categories: homologocyclic compounds, heterocyclic compounds. Let us take some example of closed chain compound cyclopropane. In this, there are 3 carbons and 6 hydrogen connected in a closed chain, and it is a closed chain. That is why we use the suffix cyclo, and other example is cyclohexane. Functional group. The functional group may be defined as atom or a group of atoms joined in a specific manner which is responsible for the characteristics chemical properties of an organic compound. There are some examples. First example is hydrolyx group OH. Second example, aldehyde group COH. Homologous series. Homologous series is a series of compounds with similar chemical properties and some functional group different from the successive members by CS2. Now, for the further homologous series, table is explained by Shiva Atre.
Good morning, sir. I am Shiva Atre and I am going to explain the topic homologous series table. In this topic, we will see that there are 6 compounds, that is methane, ethane, propane, butane, decane, and their molecular formulas are CH4, C2H6, C3H8, C4H10, and C5H12. In this group, we see that alkyne groups are on our right side. In this alkyne group, we remove one hydrogen and that single bond is kept alone. Like single bond CH3. In this, we remove one hydrogen and the suffix will also be changed as methane. Ane will be cancelled and in the place of ane, we will add yl, YL, yl. Like methane methyl, ethane ethyl, propane propyl, butane butyl, decane and decyl. Unsaturated hydrocarbons are hydrocarbons that have double or triple covalent bonds between adjacent carbon atoms. The term unsaturated means more hydrogen atoms may be added to hydrocarbon to make it saturated. The configuration of an unsaturated carbons include straight chain such as alkenes and alkynes as well as branch chains and aromatic compounds. Except for aromatic compounds, unsaturated hydrocarbons are most reactive and undergo multiple reactions to their multiple bonds. Here, this table we can see about the methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, icosane, and their molecular formula.
Good morning, sir. My name is Shivam, and today I am going to explain a cyclic compound. A cyclic compound is a term for a compound in the field of a chemistry in which one or more series of atoms in the compound is connected in a form of a ring. Ring may be vary in size, 3 atoms or 4 atoms. Include examples where all the atoms are carbon, that is carbocycles. None of the atoms are carbon, inorganic cyclic compounds, or where both carbons and non-carbon atoms are present. Depending on the ring size, the bond order of the individual links between rings atoms and their arrangements within the rings. Carboxylic and heterocyclic compounds may be aromatic or non-aromatic. In later case, they may vary from fully saturated to having a varying numbers of multiple bonds between the rings atoms. Because of the tremendous diversity allowed in a combination by valencies of common atoms and their ability to form rings, the size of the possibility cyclic structures, even small size. Here are some examples: 1-methyl, 3-propyl hexane, and cycloheptane. Types of organic reaction and mechanism. Substitution reaction. Substitution reaction, also known as single displacement reactions or single substitution reaction, is a chemical reaction during which one functional group in a chemical compound is replaced by one another functional group. Substitution reactions are prime importance in organic chemistry. Additional reactions. In the simplest term of organic chemistry, we can say that an addition reaction is a chemical reaction wherein two or more reactants come together to form a larger single product, but only chemical compounds containing multiple bonds character can undergo an addition reaction, as double or triple bond is usually broken to form the required single bonds. The elimination reaction. Elimination reaction is a type of reaction mainly used to transfer saturated compounds, organic compounds which contain single carbon and carbon bonds, to unsaturated compounds, compounds which feature double or triple carbon bonds. Besides, it is an important method to the preparation of alkenes. Rearrangement of reactions. A rearrangement reaction is a broad class of organic reaction where the carbon skeleton of a molecule is rearranged to give a structural isomers of original molecules. Often a substituent moves from one atom to another atom in the same molecule. In the example below, the substitution R moves from carbon atom 1 to carbon atom 2. Thank you, sir. And PPT of organic chemistry submitted by Shiva Atre, Samant Solanki, Shivam Upadhyay, and Ayush Upadhyay.